Assalamualaikum warahmatullahi wabarakatuh. Today, me Muhammad Syafiq Amir bin Jamrus, number matric F1086, and my partner Muaz bin Yasir, number matric F1118, want to present to you all guys about basic operation signal, continuous time signal and discrete time signal. For the first one, continuous time signal. For coding addition, we define the time vector t with a time step of 0.01 seconds and a range of 0 to 2 seconds. Using t, we define the signal x1 and x2 as sinusoidal wave with frequencies of 2 Hz and 2 Hz respectively. We perform an addition operation on this signal using the plus operator. The resulting signal is stored in a variable y, which is the sum of x1 and x2. And for the resulting signal, y is a sinusoidal wave with a frequency of 2 Hz, which is the sum of the frequencies of x1 and x2. The waveform of y is shown in the first subplot of this figure, along with the original signal x1 and x2. Second, for the multiplication continuous time signal, we define the time vector t with a time step of 0.01 seconds and a range of 0 to 2 seconds. Using t, we define the signal x1 and x2 as sinusoidal wave with frequencies of 2 Hz and 2 Hz respectively. We perform a multiplication operation on this signal using the operator. The resulting signal is stored in a variable y, which is the product of x1 and x2. For the resulting signal, y is a modulated sinusoidal wave with a frequency of 2 Hz, which is the product of x1 and x2. The waveform of y is shown in the second subplot of the first figure, along with the original signal x1 and x2.
For the shifting, we define the time vector t with a time step of 0.01 second and a range of 0 to 2 second. Using t, we define the signal x as a sinusoidal wave with a frequency of 2 Hz. We perform a shifting operation on this signal using the circle shift function, where x is shift by 100 sample to the left. The resulting signal is stored in a variable y, which is the shifted version of x. The resulting signal y is a sinusoidal wave with a frequency of 2 Hz, which is the same as the original signal x. However, the waveform of y is shift by 1 second to the left, as shown in the second subplot of the second figure. Discrete time signal. For the addition, we define the index vector in with a range of 0 to 200. Using n, we define the signal x1 and x2 as sinusoidal wave with frequency of 2 Hz and 4 Hz respectively. We perform an addition operation on this signal using the plus operator. We plot the original signal and the resulting sum using the plot function. For the result, the code above produce a plot with 3 subplots. The top plot shows the signal x1, which is a sinusoidal wave with a frequency of 2 Hz and a period of 50 samples. The middle plot shows the signal x2, which is a sinusoidal with a frequency of 4 Hz and a period of 25 samples. The bottom plots show the sum of x1 and x2, which is a waveform with varying amplitude and frequency. For the multiplication, we define the index vector n with a range of 0 to 200. Using n, we define the signal x1 and x2 as sinusoidal wave with frequencies of 2 Hz and 4 Hz respectively. We perform a multiplication operation on this signal using the operator. We plot the original signal and the resulting product using the plot function. For the result, the code above produces a plot with 3 subplots. The top plot shows the signal x1, which is a sinusoidal wave with a frequency of 2 Hz and a period of 50 samples. The middle plot shows the signal x2, which is a sinusoidal wave with a frequency of 4 Hz and a period of 25 samples. The bottom plot shows the product of x1 and x2, which is a waveform with varying amplitude and frequency.
And the last, for the shifting of discrete time signal, for the result, the code above produces a plot with 2 subplots. The top plot shows the original signal x1, which is a sinusoidal wave with a frequency of 2 Hz and a period of 50 samples. The bottom plot shows the shifted signal x1, which is the same sinusoidal wave shifted by 25 samples to the right. The shifted signal have the same shape and frequency as the original signal, but its peak occur at a different time. That's it, and thank you.